The universe is going to end. Not soon by any human measure. The timescales involved make the entire current age of the universe look like the first fraction of a second of an incomprehensibly long story. But in 2026, a research team using updated Hawking radiation models and new observational data on white dwarf cooling rates published a revised timeline for the death of everything that exists. The number they produced was dramatically smaller than the previous best estimate, in ways that forced a fundamental revision of how physicists think about the end point of time itself. The universe is still going to last an incomprehensibly long time. It is just going to last significantly less of that time than any previous model ever calculated. And the process that will end it is already measurably underway right now, happening in stars you can see with your own eyes in the night sky, whether you have ever thought about it or not. The heat death of the universe is the state that physics says all of existence is inevitably and irreversibly moving toward. A condition in which all usable energy has been permanently spent. All temperature differences across all of space have equalized completely. All stars have burned out. All black holes have fully evaporated, and nothing anywhere in the entire cosmos retains enough energy to do anything at all, forever, with absolutely no possibility of recovery or reversal of any kind. The previous best calculation placed this endpoint at 10 to the power of 1,100 years from now, a number so vast it has no meaningful analogy in any human framework for understanding scale. The 2026 revised estimate, factoring in Hawking-like radiation being emitted by objects far beyond black holes, places the endpoint at 10 to the power of 78 years. Still a number that completely collapses any attempt at comprehension, but vastly shorter than the previous figure. The universe's remaining lifespan was just cut down by a margin that is itself incomprehensible. The mechanism driving this revision is the discovery that white dwarfs emit Hawking-like radiation. Stephen Hawking demonstrated that black holes slowly evaporate by radiating energy away at their event horizons over extraordinary timescales. The 2026 research extended this principle to any region of space-time with sufficient curvature, including the surfaces of white dwarfs, the slowly cooling remnants that represent the eventual fate of most stars in the universe, including our own sun. White dwarfs are evaporating, slowly across timescales that dwarf the current age of the universe many times over, but measurably and irreversibly. Every white dwarf in the cosmos is losing mass right now. The endpoint of that process, reached across unthinkable stretches of future time, is nothing. The stars will die, the white dwarfs will evaporate, the black holes will follow, and then there will be nothing that can change, and no time in which anything could ever occur again. The universe is not ending soon, but the clock is running. It is running faster than we measured, and the process of its ending has already quietly and irreversibly begun.